Okay, so we'll be explaining the entirety of this example regarding social work statistics. So first things first, we have these number of data. So mo ni siya data na to, no? Dili ni siya arranged. So we're going to start first by finding our range so that we can create this table. So to find our range, we will find the highest value, which is 79. So now 79 here somewhere, so it's there. Minus the lowest value, so that's 8. So we have 8 here. So 79 minus 8 equals 71. So moving on, we have to look for our class width. So our class width has the formula of 2k less than n, where k are the exponent and n is the sum of values. So our sum of values here, so we have 5 rows of 10 columns, so we have 50 for our amount of data set. So we have here 50. Now the lowest possible exponent that we can use wherein it is not greater than 50 is 5. So 2 to the power of 5 is 32. So our class width is 5. Moving on to our class size or interval or I. So the formula is range divided by width. So our range is 71 divided by our class width of 5 equals 14.2, or in this case, we're going to use 14. So then we can create our class interval column. So we're going to start first with the lowest value, which is 8, and add 14. So we get 21. So 8 to 21. And then we add 1, so 22, plus 14, so 35. And the process goes on until we get to the highest possible number. The highest possible number that we can use, that it still has our highest value of 79. So we cannot stop here at 64 to 77 because we still have our highest value of 79, which means we still have to push through with another row to cater to that number, which is 78 to 91. For the frequency column, you're going to count how many values here fall within that range. So we have 8 to 21, so we have 19 values. We have, for example, we have 10, we have 8, we have 15, we have 20, we have 19, we have 21, and so on. So there's 19, and then the rest will follow. If you add all the frequency, you will get the n of 50. Next, we're going to find our class boundaries. So for the first row, for example, the formula for looking for the lower boundary, which is this one right here, is the lower boundary of our class interval minus 0.05. So 8 minus 0.05, we get 7.5. And for our upper class boundary, we have the upper boundary plus 0.05. So 21 plus 0.05, you get 21.5. Next, we have our class mark. So the class mark is determined by the lower limit plus the upper limit divided by 2. So for the first column's case, we have 21 plus 8 is 29 divided by 2, so we get 14.5. For the second row, we have 22 plus 35 divided by 2, so we have 28.5, and the column goes on. To find our cumulative frequency column, you are just simply going to add these values right here in a cumulative manner. So we have first 19, which is going to be as is, and for the second row, you're going to find 19 plus 13, so you get 32. 32 plus 7 equals 39. 39 plus 7 equals 46. 46 plus 3 equals 49, and 49 plus 1 equals 50. Now for the relative frequency column, you're going to use the formula f divided by n, or frequency divided by our n. So we have here 19 divided by 50, and you get 0.38. For the second row, you have 13 divided by 50, and that's 0.26. We have here 7 divided by 50, and you get 0.14, and so on. These values, if summed up, shall correspond to a value of 1. As for our percent relative frequency right here, you are just simply going to move 2 decimal places and add a percent at the end. Now that we have our table set, we are now going to look for our grouped mean. So our group mean has the formula x bar equals the sum f of x divided by n, wherein this one, the sigma notation, means sum of. F stands for frequency, x is for class mark, and n for the number of values. In that case, we are going to look for this part first. So the sum of f multiplied by x. So we have our frequency here, 19, multiplied by our class mark, or x, 14.5 to 75.5. We have here 13 multiplied by 28.5, and we get 370.5. You're going to do the rest of the multiplication between frequency and class mark, add that value up, and with that total value, you are going to divide it by n, or the amount of data values that we have here, so that's 50. And you will get a value of 32.7. So that is your group mean. For group median right here, you're going to use the formula median equals lower boundary of the mean class plus bracket sum of f divided by 2 minus less than cumulative frequency over frequency of median class multiplied by I, or your class interval. So we have here our definitions. LB subscript MC means the lower boundary of our mean class. This sigma f divided by 2 is the sum of frequency divided by 2. Less than CF is the class frequency lesser than the mean class, and F subscript MC frequency of mean class. So in that case, our lower boundary of our mean class would be 21.5, as our mean class of 32.7 falls in this class interval, which would give us this lower class boundary. So we have here the value 21.5 plus our bracket. So our bracket is the sum of our frequency divided by 2. If you remember, our frequency is 50, and we were going to divide that by 2, so we get 25 minus 19. Now 19 comes from here. So this is our median class, and we're going to get the median class's frequency before our current median class, and so we have here 19, which means we're going to input the value here of 19 divided by 13, or the frequency of our mean class. So that's 13 right there, and you have your total bracket. And 14 is just simply our class size, or our class interval. So solve that value up, and you get a group median of 27.924. So now we're going to proceed to our group mode. So we have a formula of L plus open parentheses f subscript 1 minus f subscript 0 divided by 2 multiplied to f subscript 1 minus f subscript 0 minus f subscript 2, close that parentheses, and multiply it by I, or the class size, or interval. So we're going to look for the lower limit of our modal class. Now what is our modal class? Our modal class is whichever row has the most frequency. So the most frequency is this row right here, 8 to 21 class interval, which has a frequency of 19. So that is going to be our f sub 1, which means that our L, or the lower limit, is also 7.5 accordingly. So from this formula right here, we have 7.5, which is the lower limit of our modal class, plus substitute the values. So we have our f sub 1 is 19. Automatically, because there is no preceding value of this row right here, our f sub 0 is automatically 0. And we're going to divide that with 2, substitute the value of f sub 1 of 19, minus f sub 0, or 0, and our f sub 2. So our next frequency is 13, so input 13 right there, and multiply with our I, or 14. Solve that equation, and you're going to get a group mode of 18.14. Now to solve our quartile, we have the formula QK equals LB plus parentheses KN divided by 4 minus CF sub B over F sub QK parentheses I. So our LB means the lower boundary of our QK class, which we will find later on by looking for this one. So KN, which means our quartile multiplied by our number of values. K is whatever quartile you are looking for. N is our total frequency, or the total amount of number that we have in our sets. If its quartile is going to be 4, if its decile is going to be 10, and if its percentile is going to be divided by 100. Minus the cumulative frequency of the class before our QK class, which we will find again later via this value, divided by the frequency of our QK class, and of course our class interval. So now we have here Q2, or quartile 2, we're looking for quartile 2. equals 21.5. Now why 21.5? It is because we have here first, so kn divided by 4. K is 2 because we're looking for quartile 2. N is 50 because that is our total frequency, divided by 4. So we're going to have 2 times 50 is equal to 100 divided by 4, and that's going to be 25. Now where is 25 in our table? It's going to be around this class interval, 22 to 35, which means that our class boundary, or our lower class boundary that we're going to use, is 21.5, as you can see right here, plus our kn over 4 minus 19. Now why 19? Because we're going to use the cumulative frequency of the class before the QK class. And so, since we have this cumulative frequency of our QK class right here, it's just 32, we're going to use the one before that, and it's going to be 19. So, over 13. 13 is the frequency of our QK class. Multiply it by 14, solve that, and you get 27.94. Now moving on to our decile 5. So our decile 5 is going to have the same formula again, but instead of 4, it's going to be divided into 10, as you can see right here. So again, why do we have 21.5 as our lower boundary of our D5 class? That is because we have here our kn over 10. So 5 multiplied by 50, and by 5 we got it from the decile we are looking for. You've got 250 divided by 10, and that's going to be 25 as well. So it basically has the same equation as the one before this, and we still get the same decile. Now we're going to look for our percentile, which is 99. So how do we get here? First, let's start with our kn divided by 100. So our k is 99, since we're looking for the 99th percentile, multiplied by 50, which is our n, or the total frequency that we have. We've got 4,950 divided by 100, and that's going to be 49.5. How do we get 49? And that's because we're looking for the cumulative frequency of the class before our PK class. So we're looking for the smallest cumulative frequency that is still the greatest or equal to our kn over 100. Using this one would not be possible because it is 49, and we're looking for something greater than or equal to 49.5. And so the next value that we have is 50, which means that we're going to use this cumulative frequency to put in this area right here, because we're looking for the cumulative frequency of the class before our PK class. Next, we have over 1. So 1 is the value of our frequency of our PK class, which is in the class interval of 78 to 91 over here. Next, we're going to multiply it with 14. This is our class size. Solve all of that up, and you get a 99th percentile of 84.5. Now let's look for our population variance and our standard deviation, and this requires us to create another table, starting with this column right here. Now, how do we create this column? We have the formula m, or midpoint, minus x bar, or our group mean. So we have here first column our class mark of 14.5. We're going to minus that, or we're going to subtract that with our group mean, which is 32.7. So 14.5 minus 32.7, and you get a value of negative 18.2. You're just going to repeat that for the rest of the values, and you get your entire column here. So for example, our last row right here, this has a class mark of 84.5. So 84.5 minus 32.7, and you get the value of 51.8. This value right here is just this entire thing multiplied to the power of 2. So as you can see, right in the calculator, we have our negative 18.2 to the power of 2, and you get 331.24. You do that for the rest of the values to get this part. For our last column, you have here the frequency multiplied by this column right here. So for example, for this row, we have a frequency of 19, and you're going to multiply that with this value. So 19 times 331.24, and you get 6293.56, which you will write it down here. For population variance, you are just going to sum up all of the values under the parentheses midpoint minus group mean multiplied to the power of 2. So add that value all up, and you get 18,130 over 49. Now, where did 49 come from? You get n, or 50, which is our frequency, minus 1. So it's 49 Solve that and you get a population variance of 370. As for standard deviation, it's basically the same value, but you put the square root in it. And so you get the square root of 372 and you get 19.23 as your standard deviation.